Hello everyone, welcome to my YouTube channel. In this video, we are going to learn how to delete an element from an array. If you know how to insert an element into an array, which I have taught you in the previous video, then it would be easy for you to learn how to delete an element from an array. Because the process is same to same, but whatever you do in the insertion, here we should do ulta of that. Suppose I have an array called as A and I have some indices and I will add some elements into this array. Now this is an array, right? And the array size is 5. Suppose I want to delete the element which is in the position 2. So what we used to do while inserting an element into an array, we used to write A of position is equal to LA, right? Which is nothing but in now required position I will insert my element ELE element. But while deleting an element, the same equation I will write it as ELE is equal to A of pos, which is nothing but the element which is in the position A of position that will be copied to ELE. So here, for example, I have taken position is equal to 2, which I have to delete the element which is in the position 2. So ELE is equal to A of 2. Position is equal to 2. The element which is present in that position, the element which is present in this A of 2 position will be copied to ELE2. So here you can see I have 5. This 5 will be copied to this element. After copying, this is how my array looks like. So there is a gap created in between these elements. So as you all know that in the array, the elements are arranged in a successively memory locations, so there should be no gap in between the array elements. To fill this gap, I have to transfer all these elements, right? So to transfer this, I will use a pointer and I will place that pointer in my position, that is L is equal to position. L is my pointer, so my pointer comes here. After transferring my pointer here, I will write A of L is equal to A of L plus 1. That is nothing but A of L is 2, right? A of L is 2 and A of L plus 1 is 3. In the A of 2, I will transfer the element of A of 3. So this element with this 2 will go here. Whereas in deleting an element, while inserting an element, we used to write A of L plus 1 is equal to A of L, right? But in deletion we have to write it ulta. This 2 will go here. The element which is present in this A of 3 will go to A of 2. So after transferring, this is how my array looks like. After transferring, what we will do next is we have to increment this L pointer. While inserting an element we used to decrement, but here we have to increment. L is equal to L plus 1. After incrementing, my pointer will come here. Again I will use this one, that is A of L is equal to A of L plus 1, that is nothing but A of 3 is equal to A of 4. Because my L is pointing to 3, so I will take L as 3 and L plus 1, that is 3 plus 1 is 4. Now again the element which is present in the A of 4 will go to the A of 3. The element which is present in the A of 4 will go to the A of 3. Simple. This 9 will go here. And again I will increment the pointer, that is L is equal to L plus 1. My pointer will come here. Now again this 3 will go up. This process continues until this condition matches. So every time it transfers each element, it comes and checks this condition. Once this condition is satisfied, again it will transfer the elements. So here now this condition is satisfied. Now what is L? L is 4. So 4 is lesser than 5. Yes, if I again increment the L, that is 5 is lesser than 5, then my condition will not satisfy, right? So my looping will stop here. After writing this condition, we have to do one last important thing, that is n is equal to n minus 1. Whereas while inserting an element, we used to write n is equal to n plus 1. That is nothing but we are increasing the size because we have added an element, right? But in case of deleting, we have to decrement because we have deleted an element. So n is equal to n minus 1 or n is equal to 5 minus 1, like this. After deleting an element, this is how my array looks like. I hope now you understood how this concept will work. Now let's go to the program. So before writing a program, I will explain I'll explain the concept. This is how it will work, because this is my way of teaching. Otherwise you would feel difficulty to write an program. Now if you understood this simple concept, then it would be not a great task for you to write an program. Let's go to the programming screen. So hello everyone, this is our programming screen. Here, before starting, I have already kept few things ready for you. Those are int a of 10. I have an array called as a, and the size of the array is 10, and I have a pointer I. To increment that pointer, I will name that pointer as I, and n to store the number of elements, le to copy that element, and p is the position. P is the position where I am supposed to delete that element. So let's start writing our program. First I will ask the user to enter the number of elements. How many elements? elements. How many elements? Then I will store that value in n, and I will ask the user to enter the elements. Then I will store order wise, starting from I is equal to 0, where I should be lesser than my number of elements. Then I will increment the I after storing each element. After that I will store the element C in a of I. After that I will ask the user to enter the position where the user wanted to delete that element. Enter the position. That I will store in P. Now here we have collected all the data from the user. Now we will start our program. Main body of the program goes here. First I will write if P is greater than n minus 1. That is nothing but if P position is greater than number of elements, then cout, then it should print that invalid position. Invalid position. Because you all can see here, first the computer asks the user to write the position, right? So by mistake, if user enters the positions which is greater than number of elements, then we should print it as invalid position. So I am writing this. After that, if the position is not invalid or if the position is valid, I will copy that element from the position. Le is equal to a of p. This a of p, which a of p is nothing but the element which is in that position, will copy it to le. After that I will introduce the for loop for I is equal to position. I will place this pointer I in the position as I have said you. After that I will state the condition that I should be lesser than n, then I should increment, right? While as I have said you, while deleting an element I should increment the I, but in case of insertion I should decrement. While deletion I should increment. I hope you got it. After writing this condition, once the element is copied, I will transfer all the elements each by writing this a of I. In the a of I will transfer a of I plus 1. A of I plus 1. Then after we have deleted an element and we have transferred all the elements, right? Now the last position is we should decrease the size of the array, that is n is equal to n minus 1. Whereas while insertion we used to write n is equal to n plus 1. But here n is equal to n minus 1. Now the elements are deleted and everything is arranged and even the size of the array is decreased. Now last position is what? We have to give the output of the deleted element. So cout, the elements after deletion are, the elements after deletion are, I have to print that in order wise, that is starting from 0, and I should be lesser than n, then I plus plus. After that I will print cout set w4 If you don't know what is this setw4, then immediately go to the insertion program which I have done in my previous video, and I will give the link in the description box. You'll come. I have explained everything, what is setw4, and without writing setw4 what happens, everything I have explained in that video. Please go to watch it there. I will write setw4 and I will write print all my elements there. Scene A of I. Then I will close the two flower brackets, as I have opened two flower brackets, but before running the program I will write get character, because I want to see the elements after deletion. And hash include conio.h header file, because I have used the getch there, right? After that I have to clear the screen. Without clearing the screen also my program will run, but the programs which I have executed before this will be erased. So I am writing this clear screen. Now everything is ready. Let's print out this program. Let's run this program. So it is asking the user, or it is asking me to enter the number of elements. This time I will say 5 elements and enter the elements 6, 7, 8, 9 and 1. These are the elements, and it is asking me the position. Suppose I want to delete 8. 8 is in the position second position. See, the 8 is deleted. The elements after deletion are 6, 7, 9, 1. Before deletion 6, 7, 8, 9, 1. After deletion 6, 7, 9, 1. This is how we delete an element. It is very easy. If you don't know, or if you're finding difficulty in learning this deletion, then please go to watch insertion program and do whatever I have done in the insertion program. It is completely ulta process of this. Or else if you are finding insertion difficulty, then learn this deletion and do ulta of the deletion to insert an element. That's it. The concept is very, very simple. Don't stress yourself. Everything we can do, but only thing is that we should have that determination of learning. So if you loved my way of teaching, then please do subscribe to my channel and hit the bell icon to get the instant notifications as soon as I post my videos. Thank you.